Hello, my name is Anne Marie Brutus, and my presentation covers the use of encryption in mobile technology. Thanks for joining. The University of Rochester Medical Center had agreed to pay $3 million to the Office for Civil Rights at the U.S. Department of Health and Human Services for data breaches it suffered during the 2013 to 2017 period. In 2010, the OCR investigated URMC concerning a similar breach involving a lost, unencrypted flash drive and provided technical assistance to URMC at that time. Despite the previous OCR investigation and URMC's own identification of a lack of encryption as a high risk to ePHI, URMC permitted the continued use of unencrypted mobile devices. How to protect mobile devices. There are many options to secure mobile devices, but a combination of a number of options is best, such as installing and enabling security software, use of password or other user authentication methods, keeping your security software up to date, install and enable encryption, research mobile applications before downloading, disable and do not install or use file sharing applications, deleting all stored health information before discarding or reusing the mobile devices. And these are just a few of some of the options that are available. Protecting healthcare data. Unencrypted data is a major vulnerability when it comes to healthcare data breaches and could also result in greater fines for healthcare organizations. Data breaches in this industry could lead to very high fines. Healthcare data encryption and the de-identification of data are two essential methods for maintaining electronic protected health information security. The terms might seem similar, and they both involve changing the readability of data or how the data can be traced back to an individual or a certain source, but they are two very different methods. What is de-identification data? The de-identification of data in the healthcare industry happens when identifiers are removed from protected health information. There are 18 different types of identifiers, which include, but are not limited to, names, telephone numbers, email addresses, social security numbers, and medical record numbers. Once these elements are masked or removed, medical information can then be used in research, policy assessment, or comparative effectiveness studies without raising privacy concerns. What is data encryption? This is when an organization uses an algorithmic process to transform data into a form in which there is a low probability of assigning meaning without use of a confidential process or key. There are two types of data that can be encrypted: data in motion and data at rest. Data in motion is when information is being sent from one individual or device to another through secure direct messaging, email, or other means of data exchange. Unencrypted data could be intercepted as it is traveling from one location to the next. Data at rest is information being stored and is not being transported. Data at rest could be on a server or even on mobile devices such as laptops or smartphones. How should encryption be configured? Deploy a combination of encryption key management that is tied with blast radius analysis. This means that not all of your data is underneath a single encryption key. Multiple encryption keys will help the organization be more secure. If one of the many keys is compromised, then not all of the data is compromised. Encryption key management is the administration of tasks involved with protecting, storing, backing up, and organizing encryption keys. There are several encryption key management standards efforts underway currently. The best known is the Key Management Interoperability Protocol, KMIP. This was developed by vendors and submitted to the Organization for the Advancement of Structured Information Standards, OASIS. The goal of KMIP is to allow users to attach any encryption device to a key management system. Cryptographic key management types. Encryption keys apply complicated algorithms to data and then convert that data into streams of apparently random alphanumeric characters. There are two types of cryptographic algorithms: symmetric, otherwise known as private key, and asymmetric, otherwise known as public key. Symmetric key algorithms use a single key to secure communications and achieve confidentiality, integrity, and authentication. A private key is a variable that is used with an algorithm to encrypt and decrypt code. While the algorithm doesn't need to be kept secret, the key does. Asymmetric algorithms provide each user with a public key and a private key. Users can freely distribute the public key while keeping the private key secret. These key pairs achieve all four goals of cryptography: confidentiality, integrity, authentication, and non-repudiation. A public key infrastructure supports the distribution and identification of public encryption keys, which allow users and computers to securely exchange data over networks such as the Internet and verify the other party's identity. Blast radius analysis. If we placed all of our data within one file or database, the loss of that database would have a very large blast radius. All of the data would be gone. However, since we break our data into manageable chunks, files, databases, or spreadsheets, the loss of one file does not mean the loss of everything. Therefore, our blast radius is smaller, and this is what we definitely need to try and achieve. In conclusion, let us note that data encryption and de-identification of data make a powerful team when it comes to ePHI. Granular encryption and key management also allows you to erase the data forever by merely deleting the associated encryption key. Can you imagine a file deleting feature that merely discards the encryption key, thus rendering the data cryptographically erased and unrecoverable? Would rewriting with ones and zeros even be necessary? Sure. To feel better, you could rotate the bits of the key, but it would take a lot less time to scrub the bits of a 256-bit key than it would for a 1 gigabyte file. Do these protocols and methodologies make the healthcare industry future-proof? Absolutely not. There is definitely a need for the industry to update its technology and its methodology. Thank you for listening to my presentation. I would also like to give thanks to the references that was provided during this research. I got information from about 5 articles. One article, the first article is How Can You Protect and Secure Health Information when Using a Mobile Device? The second article is Research Center's failure to encrypt mobile devices leads to $3 million HIPAA settlement. The third article is minimizing the encryption blast radius. The fourth article is what is encryption key management? And the fifth and final reference is the difference between healthcare data encryption and de-identification. Thank you.